Hello, UC Davis College of Engineering alumni, parents, students, prospective students, faculty, staff, and friends, and happy Engineering Week to you. It's E-Week here at UC Davis, and we are celebrating by kicking off this fantastic event. Welcome to our winter quarter edition of Engineering on Tap. I'm Leanne Hartman, Assistant Dean of Development and External Relations for the College of Engineering here at Davis, and your host for tonight. So launched in 2019, the Engineering on Tap series has been a way for us to learn something new about the College of Engineering and connect with new and old friends. This is now our 7th EOT, and I want to give a special shout out to you who have attended multiple events. I know that we have some repeat offenders on tonight. Whether you be in person or on Zoom, we have want to thank you for showing up and for being here tonight. So we get the privilege of hosting tonight 3 of UC Davis's most accomplished engineers: Chancellor Gary May, Dean of the College of Engineering, Richard Corsi, and Vice Provost and Dean of Graduate Studies, Jean-Pierre Delplanque, also known as JP. We look forward to a robust conversation about the future of engineering education. I know that education certainly has changed a bit since I was a student over 20 years ago, and it has drastically changed even more since the start of the pandemic in 2020. So I'm really looking forward to hearing what these incredible engineers have to share from their lens. A few housekeeping notes before we start tonight. This event is being recorded, and we will be posting it on the College of Engineering's YouTube channel next week. Please use the chat to submit your questions. We want to hear from you and what's on your mind. And we'll try to get through as many of these questions as possible this evening before 6 o'clock. And finally, make sure you stick around to the very end to be part of our raffle. We will be raffling off 2 $25 e-gift cards to the UC Davis bookstore so you can stock up on your Aggie gear. Without further ado, I'm extremely excited to introduce our moderator for our conversation tonight, JP Delplanque. Dean Delplanque has served as Vice Provost and Dean of Graduate Studies since January of 2019. In his role, he is focused on cultivating an inclusive, equitable learning environment for graduate students and postdoc scholars, so they are equipped to spearhead discoveries with global impact. JP is also a professor in the Department of Mechanical and Aerospace Engineering. Where's my MAE alums? His research focuses on the multi-scale modeling and numerical simulation of complex fluid and thermal processes and systems. Thank you, JP, for leading today's conversation, and I'll turn it over to you.
Thank you, Leanne. I'm very excited to be here today and to be joined by Chancellor May and Dean Corsi. Let me start by properly introducing our 2 panelists. Chancellor Gary S. May is an accomplished scholar and engineer who came to UC Davis in 2017 after a 3-decade career at the Georgia Institute of Technology. There, he was Dean of the Institute's College of Engineering, the largest and most diverse school of its kind in the nation. With degrees in electrical engineering and computer science and hundreds of publications to his name, Chancellor May has received numerous honors for his research in computer-aided manufacturing of integrated circuits, including induction to the National Academy of Engineering and election to the American Academy of Arts and Science. As Chancellor, his vision is to lead the university to new heights in academic excellence, inclusion, public service, and upward mobility for students from all backgrounds. Welcome, Chancellor May. Dean of the College of Engineering, Richard L. Corsi, returned to UC Davis, his alma mater, in September of last year, nearly 3 decades after graduating with MS and PhD degrees in civil and environmental engineering. A leading expert in the field of indoor air quality, you may recognize Dean Corsi from the news. He has been engaged in national discussions related to layered risk reduction to reduce transmission of COVID-19 by aerosol particles and featured in more than 100 print, television, and podcast interviews. Early in the pandemic, his efforts focused on lowering inhalation dose of virus-laden aerosol particles indoors. His concept of a low-cost and effective do-it-yourself air cleaner to combat virus-laden aerosol particles and wildfire smoke has become known worldwide as the Corsi Rosenthal box. As Dean of the College, he looks forward to inspiring students, investing in strategic areas to advance research and education, growing our impact, increasing visibility, and sustaining a strong community of scholars. Welcome, Dean Corsi. Now to our conversation. Our focus today is the future of engineering education, and specifically how UC Davis can and will make an impact. First, let's get our bearings. What is the current state of engineering education, and how are we training engineers for a 40+ year career in engineering? Chancellor May, would you like to go first?
Sure, thanks, JP, and thanks for having me. This is a wonderful opportunity and a great event. First, let me just say, I think UC Davis is a great place to study engineering. We're in a region where engineers are now and will continue to be in very high demand. UC Davis graduates are filling a pipeline of talent in not only engineering, but also software development, biotechnology, many other fields, locally in Silicon Valley and elsewhere in the Bay Area and the entire state, and the country for that matter. We provide an environment where innovative ideas can propagate. We enable our students, our faculty, and our researchers with the resources, the mentoring, and the inspiration they need to take an idea from the laboratory to the marketplace. And we're also creating some new spaces where this innovation and entrepreneurship can really thrive. I'll just give a couple of examples. The Student Startup Center, which serves as all UC Davis students who are interested in the entrepreneurial process. It's part of the College of Engineering's innovation ecosystem with numerous design clinics and programs to encourage student innovation and support multidisciplinary teams working on real world projects in a variety of disciplines. Secondly, we have the Diane Bryant Engineering Student Design Center, which is the hub of the college's innovation enterprise. This center provides a space where students will learn all phases of the design process, from project framing to creating business models and everything in between. And lastly, I'll just mention something I'm really proud of, Aggie Square, which we broke ground on just last week. This will include a new maker space where business partners, students, engineers, doctors, all will work side by side with community members. And at Aggie Square, in particular, biomedical engineering supported their undergraduates, learning how to move ideas from bench to bedside, as well as graduate students studying medical device development and many, many other things. But I'll just stop there and let the dean hit a little bit.
Thank you, Chancellor May. Dean Corsi, what do you think?
Yeah, so thank you, JP. And first, let me thank everyone out there for joining us today. I really appreciate your time and your interest in the engineering profession, and especially the College of Engineering at UC Davis. So I'll also say it's wonderful to have a chancellor who's an esteemed engineer, but it also makes it difficult to follow him on such questions. So I'll start by saying unequivocal agreement with everything that Chancellor May has just said about the College of Engineering at UC Davis. I'll just quickly address the issue of where I think engineering education is today in general, not just UC Davis, and then quickly return to some of the points that Chancellor May just made about UC Davis. So one thing that has not changed in our profession is the importance of learning fundamental scientific and engineering principles that we use to design, build, test, and apply systems that address or solve problems of relevance to society, obviously. This is really the foundation that allows our graduates, when they graduate, to pivot and to go in different directions during their careers. And in my own case, my PhD and the work that I started doing after finishing my PhD at UC Davis is focused on chemical transport and raw sewage and the fluid mechanics of sewers. And during my career, I was able to pivot to sort of the inside of buildings and building science and indoor air quality. And I was able to do so because of the great public education that I got in the state of California, including years at UC, a lot of years at UC Davis. So I think fundamental principles are important and they're not going away. We need to continue to teach those. Three things that I think are rapidly changing and that we need to adapt to in engineering education are an extreme gradient of new technologies that are kind of coming at us all the time. Miniaturized and low-cost sensors, new materials, opportunities for massive data collection on just about everything from what you purchase at the grocery store to environmental conditions 100 meters from freeways, right? So we got this massive amount of data coming at us with these new tools, massive challenges related to climate change, population health, cyber threats. And then thirdly, I think a substantial gap between very well-served communities and underserved and historically marginalized communities in our society. So I think that in the future, we see engineering education continuing to focus on fundamental principles, but also infusing how we harness new technologies to address bigger and more complex problems, and also how we do that in a way that we do it for the greater good of all of society and don't leave anybody behind. And I think UC Davis is really well positioned to lead and help transform engineering education in the coming decades, starting with the fundamental principles, but also bringing in some of the human factors that I just mentioned. And Chancellor May articulated some of our great assets that we have here at UC Davis. We're creating an innovation ecosystem around the Diane Bryant Engineering Student Design Center, entrepreneurship around our Student Startup Center, and the growth of Aggie Square that allow us to connect our College of Engineering with industry and community. So I think that the road is paved for us at UC Davis. And I think our whole community is champing at the bit to lead engineering education into the future.
Oh, excellent. That's actually a nice segue into my next question. Since we're talking about the current state, looking to the future now, what are some of the biggest challenges the world is facing in the next 10 years, and how is UC Davis Engineering positioned to tackle them? And Dean Corsi, if you want to start, since.
Okay. I want to underscore that the challenges are important worldwide, as you mentioned, but also very important to our own state, right? California is the 5th largest economy in the world. We're the breadbasket of the world. We're the innovation hub for the world. What happens in California impacts the entire world. So I think if we focus on what's great for our state, we will have a great impact on the world, from food production to healthcare for all, pandemics, cybersecurity, and so on and so forth. There's so many critical issues that our society faces that engineers are focused on, right? These are the things that we can really make a significant dent in terms of solving. Climate change, I think the next 10 years are so critical in terms of the magnitude of the challenge that we'll face for the next 100 years. If we don't get it right now, we're going to be in big trouble, right? So we need to start now. We need to get it right now. And that means engineering innovation, determination, and action. I'll add mobility also to the list, how we get from point A to point B in the future, or whether we even need to get to point B anymore in the future, how we help those who struggle with mobility. I think we're on the cusp of great changes in terms of mobility. So climate change, healthcare, mobility, and then also this huge challenge that I already alluded to, that we need to make sure that we leave no community behind. What engineers do affects everybody. And as such, I think the engineering discipline needs to become far more diverse and inclusive and be focused on technologies and engineering solutions that benefit all. You asked how UC Davis is positioned to tackle these issues, I think. In terms of advancing population health through engineering, I feel strongly about this. There's no College of Engineering west of the Mississippi that's better positioned than us to make major contributions to population healthcare. We have an excellent biomedical engineering program. We have faculty across several other departments that are working on health-related issues. We have a top-notch school of medicine, a medical center, the #1 school of veterinary medicine in the world. We have the CERM Alpha Stem Cell Clinic, the California Primate Center. No other university has all of these assets at its disposal. And I think we're just so positioned to make major contributions to improving healthcare. And on climate, UC Davis and our College of Engineering has a sustainable ethos that is second to none. We're highly recognized by others in this respect. It's what drew me to UC Davis as a graduate student in the 1980s. It's what partially drew me back to UC Davis. And this past fall, it's who we are. And I think that we have the will, the determination, and the expertise in place now to lead efforts around climate mitigation and resiliency. We're already probably #1 of the world in sustainable transportation systems, and we need to continue that. Because of our roots, I think we have a foundation and a hunkering to better all, not just some of society, through education, research, and community service. And so I think our state, our nation, our world face big challenges. And I really feel good. And this isn't just because I'm biased as dean, but I feel really good about who we are and where we are in terms of our College of Engineering assuming a leadership role in addressing these kinds of challenges for decades to come.
Thank you. Chancellor May.
That was Dean Corsi's turn to take all the good answers.
Sorry.
I'll just say that I agree. Most of the greatest challenges that we face today are global: environment and climate change, food production, natural resource depletion, healthcare, the threat of pandemics, which is we're all too aware of now. I will try to build on some of the things that Dean Corsi was saying with respect to engineering sharing this responsibility in an interdisciplinary way with some of the other experts on our campus. Our engineering faculty are doing the interdisciplinary research that improves lives, makes the world a better place, but they've also teamed up with other folks around the campus. Now, I'll focus first on our COVID-19 response and solutions. The College of Engineering worked with the School of Medicine to develop technology for producing ventilators and 3D printing test swabs very early in the pandemic, which was really important for our local response. Davis engineers invented shaking and inversion machines that are now a real critical part of the Genome Center's award-winning asymptomatic COVID testing program, which has been indispensable for our campus. And the civil and environmental engineering faculty partner with veterinary medicine faculty to manage our wastewater monitoring program for Healthy Davis Together, which is an effort that helped to provide information about the spread of COVID-19 in Davis and Yolo County. And I'll just mention a couple other things that engineering faculty are doing in teaming fashion to contribute to sustainability in healthcare. Biomedical engineering professor Simon Cherry teamed with Ramsey Badawi from School of Medicine to create the world's very first full body PET scanner. And this device will improve the screening and detection and diagnosis of many life-threatening diseases as it's used. And Davis engineers were part of a team that created smart prosthetics and a novel amputation surgical procedure that helps patients to better control their residual muscles, receive sensory feedback, and reduce limb pain. So I think the really cool thing about UC Davis engineers is that they have a pretty good grasp on what the problems are and are willing to team with folks with other expertise around our campus to really have impact. And I think those examples show that.
Thank you. What do you think needs to, or maybe inevitably will change in how we educate engineers?
Is it my turn to go first?
If you want to go first, yes.
Okay. Well, one thing I always tell people is we need to prepare students now for jobs that may not exist right now, right? And we need to prepare students to create their own jobs if necessary, right? Entrepreneurship. We also need to provide some hands-on experiences that will make our students competitive. As we talk about global competition with countries like China and India, we're not going to win on volume because there are many more people in those countries, right? Many more engineers being produced. So they're going to have to be innovative. And some of this stuff happens in the spaces I already mentioned, the Diane Bryant Engineering, the Student Design Center, the Student Startup Center, Aggie Square. We're also doing it through some of our business partnerships like Avenue E with Chevron as our partner. And I think we also need to figure out how to diversify engineering and prepare students to succeed in an increasingly diverse and global workforce. Women and minorities have traditionally been abysmally underrepresented in our field. And that's something that just has to change for the sake of better outcomes, not just because it's a good thing to do. And it just produces better outcomes. For example, we've seen some consequences when we didn't have diversity, like the first airbags in the auto industry almost killed women passengers. They were deployed and they were tested on crash test dummies that had male anatomy. So when they deployed, they hit the women right in the head, snapped their necks back, almost killed them. The first speech recognition devices, if anybody remembers Speak and Spell, didn't recognize women's voices. If you fast forward to today, pulse oximeters that are used to monitor oxygen levels for COVID-19 patients don't work as well on people with darker skin like me. Same is true for facial recognition software. And my point is, if teams that designed those devices were diverse, they might not miss those points, right? So diversity not only is the right thing to do, but just leads to better outcomes in general. I'll stop there.
Excellent example, thank you. Dean Corsi?
Yeah, so I want to underscore everything that Chancellor May said again. Right on, sign me up. It's why engineers have to think about all of society, and I think this is such an important question. Going back to the question, I think the question was inevitably how are we going to change how we educate engineers? That was it.
How do we change how we educate engineers? Yes.
All right. So I think obviously some things we will not change. I already mentioned fundamental principles. We're not going to change Newton's laws, but I do think that where we're going to see change, it's going to be on the human factor side. Some of the things that Chancellor May mentioned, and we need to do better as a profession in that respect. So a few examples. I'm going to break these up into, in my mind, 3 or 4 different categories. One is greater good. I think students of engineering develop skill sets that can do so much good for all of society. And I think that in educating engineers, we need to emphasize that more. The power of engineering to do good is extraordinary, and to instill a relentless spirit of pursuit for the greater good of society is something that we should be bringing more into the educational process. And by that, I mean all of society, nobody left behind. Secondly, to underscore what Chancellor May said, diversity. I do not believe we can realize our potential for the greater good of society without increasing diversity in our profession, starting in our colleges of engineering. We need to embrace the tremendous value of those who bring different life experiences to engineering solutions, more diversity, being more inclusive, and we need to celebrate the importance of diversity for the greater good of society. 2 that have always been important to me for personal reasons is one, inspiration. And I'm keeping with kind of the non-technical human factors that we as engineers need to deal with. Is we often focus on being good teachers and mentors in universities, but we don't focus or discuss enough the importance of inspiring our students to take on great challenges and to do great things. And I think in the future, we need to find more ways of doing so and figure out how we can best measure inspiration as an outcome of what we do. That's a hard thing to do, but we need to figure out ways of doing it. And I want us, the College of Engineering at UC Davis, to be known. If down the road, when I'm no longer dean anymore, I want to look back and say, we became the College of Engineering in the country known for inspiring our students to do great things. And that needs to be built into all the things we do as in part of the educational process. And then finally, very personally, I think focus on building and lifting the potential of our students and providing them with the confidence that we need to succeed. We have an increasing percentage of first-generation college students in engineering, and I suspect many have never had role models in their lives who are engineers before entering college. And I can speak from experience. I'm a first-generation college student. I'm a first-generation American and college student. My mother did not get past the 6th grade. It was hard because we had to help my mother to add and subtract and do basic math. My father got his high school diploma going to night school when I was 5 years old. I had no engineers in the family. I had no engineers as friends, my friends' parents. I had no role models at all in engineering. And I was absolutely convinced every day in college that I would be a failure. And we talk about imposter syndrome. That's a term we talk a lot about now. We didn't talk about it back then, but I had imposter syndrome for sure. My confidence grew when I got away from theory, when I got away from books and actually started building things and sometimes breaking things and then building them again. We didn't have the assets of the Diane Bryant Engineering Student Design Center when I was a student, when I was in college. We did not work much on teams or with our hands. And had we had resources like our Engineering Student Design Center, I think I would have hit my stride with respect to confidence much sooner. And so I'm so excited about the assets that we have in our College of Engineering and our ability to use those to build confidence in all of our students.
Thank you. Thank you for sharing that. And this importance of learning to fail to go farther. We may touch upon it a little bit more later. My next question, you both touched upon a little bit already. I'd like to dig in a little bit more. That's about the important skills, the most important skills that young engineers can learn at UC Davis to prepare them for, I'm going to say graduate school, of course, but any career in engineering. Dean Corsi.
Right. So, boy, there's so many. And I'll just give you a few. And these are probably going to border on sort of the human side of things again, because I think we already do a great job on teaching fundamental principles. Our students are already coming out with really strong engineering educations. But I think that looking to the future, we need to be thinking about additional skill sets. And so I'll start by saying nimbleness is one. The world is changing rapidly. Our challenges are changing rapidly. Technology is changing rapidly, the things I mentioned in an earlier question. And what we used to see as decade-long changes are now happening almost in real time in our world. So being nimble and responsive to change requires that foundation in fundamental principles. It also requires a growth in confidence that I mentioned earlier to effectively take on new challenges as they're coming at us, and an understanding of when and how to pivot. And that comes from experience, listening to others, and historical perspective. And I hope, all colleges of engineering start infusing more of those kinds of attributes into the educational process for engineers. Second is working across disciplinary boundaries and with those that bring different life experiences to the table. Chancellor May has already mentioned that. I alluded to it, but the problems that engineers will face in the future are frighteningly complicated. And these problems necessitate engineers in one subdiscipline to work with engineers in other disciplines, but also in the physical and biological sciences, with social scientists and more. And it requires the input from those who come from different life experiences, from communities most impacted by the challenges we face. So we should prepare our students for these opportunities through, working on problems with those in other disciplines, working on teams with those in other disciplines, embracing the importance and value of diversity, equity, and inclusion for solving problems. I think if we fail to do that, we fail as a profession, but we also put our society at peril. Perspective is something we don't talk enough about. Studying the profession, what's been done by others in the past, where, when, and how did they succeed? How did they fail? Why did they fail? I see a lot of new researchers in my own field coming into the field without a clue of what others have done in the past, wasting time through repeating what others have done, failing by not understanding how others have failed. So I think that perspective is important. And then finally, and this is something that is really important to me, is that engineers have traditionally not been educated to become leaders in their profession and beyond, not just the engineering profession, but policy, et cetera. So development of leadership skills can and should be a really big part of engineering education. And that can be taught in the classroom, but it's also really important that it's done through connections and interactions with leaders in the profession, including those not on the campus, opportunities for leading student teams and competitions, engaging in startups, and more. And I think as educators, we ought to be doing all we can to open up leadership experiences and opportunities for our students.
Thank you. Chancellor May?
Yeah, that was a great answer. Rich, I can only add a few things to that really great list. I would say, the ability to adapt to rapid change. There's an insatiable quest in society to do things faster, cheaper, more efficiently. AI and machine learning are pervasive now. We've seen widespread automation. I mentioned 3D printing, print-on-demand technologies, along with move toward technology-assisted quality control and approval processes that use AI, in fact. We don't know what new innovations are coming, but if we look at the past 2 decades as any indication, we can expect that every industry will be impacted by this rapid technological development. Secondly, I'll just mention the ability to thrive in a diverse and highly collaborative environment. As I said, this is going to be necessary if we're going to solve the world's problems in such a way that the greatest number of people can benefit from those solutions. And lastly, and this sounds kind of Pollyanna-ish, but I'll just say it this way: make the world better. A focus on making the world better, not just creating the coolest, newest gadget. But as educators, I think we have a special calling and responsibility to help prepare and empower our students to do things in such a way that it improves the quality of life for our fellow human beings.
Excellent. Thank you so much. Okay, so it's an exciting time in the College of Engineering with Dean Corsi's arrival, and he has already hit the ground running with a strategic visioning process. So Dean Corsi, this one is for you. What's your approach? Any teasers about what we can anticipate coming up?
So you may have to cut me off on this one, JP. I'm really excited about our efforts to develop a new strategic vision in the College of Engineering. We started in October 21 with parallel efforts around a strategic research visioning process and a strategic education visioning process. And the goal is ultimately to connect the two and develop a really detailed action plan to lead to continuous leadership by our college. But we're not there yet. So we're kind of halfway through the process right now. You mentioned what is my approach. I don't want to take credit for the approach because there's a lot of people involved. So, I established the importance of developing a bold vision and the general framework. And then I turned the research vision over to our very capable Associate Dean for Research, Christina Davis, and her team, and the education vision process over to our very capable Associate Dean for Undergraduate Studies, Ralph Aldridge, and our Associate Dean for Graduate Studies, Roland Fowler. And I want to make clear that this isn't my approach. It's a major effort involving a lot of really capable colleagues and stakeholders. So I'll just focus on the research front real quickly. On the research front, we're striving for the following. We can't be everything to everybody. And so the question we're asking is, what are the 4 major societal challenges for which our college is poised to make major impacts and to be considered amongst the top 3 or 4 in the nation in addressing those challenges? So these need to be major challenges that necessarily require interdisciplinary collaboration within our college, across colleges on the UC Davis campus, but also with external partners. And then, so 4 major challenges, and then up to 3 important cross-cutting areas of relevance to all of those challenges. So this construct is going to become our roadmap for informing future faculty hiring, investments in equipment, new partnerships on and off campus, et cetera. So I'm very excited about getting that off the ground. It'll become our roadmap. For the research visioning process, we started with a survey of all of our faculty. We received 450 ideas amongst all of our faculty for these challenges we should take on and crosscuts. There's a lot of overlap. And then faculty were brought together for 3-hour brainstorming charrettes with one faculty member from every department at each table in this process to kind of explore and refine and slice and dice and add and subtract from that long list from the survey from all of our faculty. And then that information went to our leadership team. And we're now asking teams of faculty from across departments to pitch bold ideas around these vertical challenges and also our horizontal cross-cutting areas. So without getting into a lot of details, you asked for a teaser, I think. So I'll say that the research construct is heavy on taking on challenges related to the future of energy, including, focus on climate mitigation, as well as climate resiliency, human health. As I said earlier, there's no college west of the Mississippi, if not the entire United States, that's better positioned to take on big human health challenges than us, and also mobility. So those are our 3 or 4 big challenges that we want to take on. And we've converged on cross-cutting themes that support these challenges, particularly cross-cutting themes of artificial intelligence and automation, miniaturized tools at the nano and micro scales. And then one that I'm really excited about that was a grassroots, a real grassroots statement here that our college wants to take on technologies that serve the greater good. And so I'm really excited that that's going to be one of our cross-cutting areas. We're branding that construct. It will be our vision for the next 5 to 7 years for research. And on the education side, we have a separate process that's addressing questions like, how can we provide a truly unique engineering education with significant value added for our students, leveraging all the kinds of assets we talked about earlier, a new Diane Bryant Engineering Student Design Center, et cetera. How do we continue to broaden participation at both the undergraduate and the graduate levels to harness the benefits of bringing aspiring engineers who come from different life experiences together? And then how do we inspire students on a continuous basis? How do we inspire a student from the first day in our college to the time that they walk across stage at graduation, and then carry that inspiration throughout their careers to do good for society, as Chancellor May mentioned in the last response. So we're branding the overall vision as next level. We should be, hitting on all cylinders or so by fall of 2022. And I'm just really excited about our progress and seeing where we're going to get at the next level.
Hitting on all cylinders here is a metaphor that works for a mechanical engineer. Thank you for that. Chancellor May, you established the widely read to boldly go strategic plan for the university. And so you must have some advice for Dean Corsi as he formulates a strategy at the college level. It's a difficult endeavor.
Yeah, it is a challenge, but sure, I'm very excited to hear some of the plans that Dean Corsi just elaborated on. I think it's a really compelling foundation for a vision for the college. So I'm excited about that. But I think, the building blocks of any strategic plan can be found by just identifying the strengths that make your college distinct and unique, strengths that can be leveraged to raise the profile of the college and the university, of course. It's important to get lots of feedback from all stakeholders, students, faculty, staff, alumni, community, on and on and on. The list goes on. Get lots of feedback from stakeholders, because the universe of people who are truly interested in our success is usually larger and more diverse than you could imagine. And so make sure that everyone gets a chance to have some input. In fact, I would say that that process where you're putting the plan together and the buy-in that you get from the community of stakeholders is just as important as the final product of the plan itself. And hopefully, Rich, you'll align your efforts to support the UC Davis strategic plan overall, so that they won't be orthogonal to each other. So that'll mean, incorporating some of our ideas around innovation, entrepreneurship, DEI, all the things that I've heard you mention anyway. So I know that that's going to happen, and consider some of the partnerships that'll help provide the experiences that we want our students to have to be competitive.
In Corsi, you want to respond, follow up?
No, I mean, it's great advice, and we certainly are in the process. Where we are right now is moving to the process of getting a lot of feedback from lots of different stakeholders, and some of the things that Chancellor May just mentioned are going to be critical to particularly our education vision, and so we want to bring all those things in. So thank you.
Okay, well, thank you both. It sounds like we have a lot to look forward to. So thank you both for sharing all that wisdom with us today. We're now going to transition to audience questions, and some have been posted in the chat already. And so you can keep doing that. I'm going to start with a question I have here. You spoke earlier about the important skills young engineers can learn to become a successful engineer. How did you overcome some of your own biggest struggles to become an engineer? And I'll let you decide, who wants to speak to that first.
I can start. I mean, I think where I struggled, and this was kind of an artifact of how engineering was taught when I was an undergraduate. We learned a lot about how to do things, but not a lot about why. So we learned, for example, how to solve a PDE, a partial differential equation, and with certain boundary conditions. I know I'm getting JP excited here, but but we didn't know what we were going to use that for. And one analogy that I think is perfect for this: if you play sports, let's pick baseball as an example. We were taught how to throw, how to run, how to catch, how to hit, but we never scrimmaged, right? We never played until our senior year. So I struggled with really motivating myself to learn all those hows and without the why, the context of why we were doing it. And I think that's one of the things we're improving upon now with what we're doing at UC Davis with the various the design center and the startup center. We're teaching the why in conjunction with the how, so students can appreciate both.
In Corsi?
I agree with all of that, absolutely, and I think I alluded to that earlier. Is that I gained confidence when I got out of the books and out of the theory and had an opportunity to work on projects and build things, and I think a great lesson for me was trying to build something and having it fail and break, and going through the frustration of having to do it again or rethink how I built it, and then finally getting to the point where it works. It's amazing how a light just goes on at that point, and the confidence level just increases, and it just makes it easier every time you take anything on. As I mentioned earlier, I didn't have any role models growing up, and one of the things was great for me was that when I was an undergraduate student, there was one professor who took an interest in me and became a mentor for me. That helped my confidence. And when I got to UC Davis at graduate school, I had 3 professors that I can think of in graduate school who really took an interest in me. And I feel like I had more than one mentor when I was at UC Davis. And they helped me so immensely in terms of direction and confidence. So it is amazing. And this is something that all academics, I think, have to realize, is that those touch points with students, those times where you pat them on the back and you tell them it's going to be okay, and you sit down with them and you advise them. I mean, those short moments, they might be 15-minute conversations, sometimes are more important than entire courses that students take. So that was a struggle for me, but that's what helped me get through.
Yeah, I think we all agree that of the importance of mentoring and experiential learning, actually, that cannot be overstated. Sticking on with the theme of skills, an audience member asked, the rest of the 21st century will be as much, if not more, about adaptation to climate change rather than mitigating the causes of climate change. How is UC Davis Engineering preparing future engineering professionals to effectively address climate change adaptation problems in different parts of the world?
I think I'll give that one to Dean Corsi.
So, well, I think it's a great question. And I'll start by saying, think of another university or college of engineering in a university that's better positioned to do that, right? When you think about the impacts of climate change on feeding the world, on food production, on water, on drought, the things that our own state faces and that we have to overcome, and how we overcome things in the state of California will help overcome things in other parts of the world related to drought, energy security in the face of climate change, helping those that are most impacted through various means in when we have major climate perturbations, whether it's flooding or heat waves or whatever it is. So I think from a research standpoint, we're really well positioned. I think we do need to find ways of infusing those big challenges of climate change into everything we do, even on the educational side, right? So whether that be infusing into courses, maybe there's opportunities to infuse issues of climate change, just like we should be infusing issues of social and environmental justice into our courses, infusing climate change. And then outside of courses, having opportunities for students to come together and work on challenges and competitions, and to encourage students to do that, to learn skill sets that'll help them as engineers over the next 40 years as we continue to grapple with having to adapt to the ravages of climate change.
All right. Chancellor May, would you like to add anything?
I think that was a great answer. And I really like the framing of the question. In fact, I think whoever asked the question, that's exactly right. We're going to be less able to mitigate the causes of climate change as we get further and further away from, we had an opportunity to do it, years ago, we didn't do it, but we're going to have to figure out how to live with it and to adapt to it and alleviate some of the effects.
Yeah. And if I can add one thing, because we don't, sometimes we think about climate change and we think of environmental issues, and that's how we think, but it affects so much more, right? It affects our economy, it affects our national security, it affects the military, it affects our ability to manufacture when power is going out, all the time. So it affects healthcare. There is so much impacted by climate change that engineers across engineering disciplines, not just environmental engineering or something else, have to worry about, and we should be incorporating those things into teaching across disciplines.
So somewhat of a trick question here. What skill or skills are UC Davis engineers lacking when they graduate, and what is being done to close this skill gap?
That is a low.
Go ahead, Chancellor May.
Well, I to be honest, I don't know what skills that our students are lacking. I don't think I'm in the right position to answer that, having not been here very long, and similarly, Rich, neither of us has been here that long. But I will say that engineering students in general, not only lacking the how versus why thing that I talked about earlier, but also the context for how their devices, processes, programs are used. And I talk about making the world a better place. So I think one of the things we need to do better, we engineers, not we UC Davis engineers, is partner with our colleagues in humanities and social sciences and some of these other fields to really be able to contextualize the devices and processes and programs and things that we're developing and for their best, most highest purpose and use. And so I look forward to being able to do that better here at Davis and elsewhere.
In Corsi?
I have nothing to add to that. I agree 100%. And I think we've also touched upon some of this question with some of our previous questions.
No,
I think it's a really important question, but I don't have anything to add.
Thank you. How does UCD diversity, equity, and inclusion, how do those initiatives impact the engineering curriculum?
Well, I'll tell a quick story and then I'll let Rich jump in. But when I first became a dean in 2011, I was dean of engineering at Georgia Tech. And the very first week or two after I got on the job, I got a memo, anonymous memo in my inbox that basically the gist of it was why all of this DEI stuff is ruining the quality of the engineering program. True story, right? It's lowering standards, all these things, all these, things that you hear. The truth of the matter was, at the same time as that College of Engineering was becoming more and more diverse, rankings were rising, research awards were going up, everything you could measure was improving. So this notion that DEI is somehow detrimental to the overall, I'm not saying that's what the questioner was saying. Please don't misunderstand me. I'm not accusing the questioner of taking that tact, but some people do. And in my view, these things are not mutually exclusive. What we do in DEI actually reinforces what we're trying to come across, what we're trying to get across in the engineering curriculum.
Thank you.
Yeah, so it's a great question. I was just scribbling down notes, so that's why I'm looking down at my page here. But I think that, to underscore what Chancellor May said, when you bring people together that come to the table with different life experiences, you're much better at solving big problems, because you need those perspectives, because of everything that engineering does affects all of society. We can't not have the experiences of those that come from backgrounds where somebody like me growing up may not understand the perspectives of somebody who comes from a different life experience. And it's just so important that we bring people together, right? And that means adding diversity to the engineering profession. That means starting K through 12 to get, kids excited about STEM. That means providing an inclusive and welcoming environment for those who come to our College of Engineering. It's just so important. And I've seen the same thing that Chancellor May said when I was at the University of Texas at Austin, is that we went through that sort of same trajectory, and all of a sudden our rankings got better. Our community improved in ways that it's just too hard to explain here, but just really improved. So that's important. In terms of curriculum, because the original question was curriculum. And I do think we have opportunities to infuse issues into our curriculum that do a better job of reflecting the life experiences of everybody who is in our college, right? So that's infusing issues of social justice and environmental justice. I think of transportation engineering. Transportation engineers over decades and decades and decades build freeways through cities and don't realize what the impacts of their design has on dividing people in cities as opposed to bringing people together in cities. It's just one example. And I think engineers have the ability to be thinking about how to improve society as a whole by doing a better job of designing for society as a whole. Just as one example that I jotted down. I think that, outside of the classroom, this isn't really curriculum, but it's activities for our students. We have an amazing group in the College of Engineering, and it's called the Women Machinists Club. And I recently met with them. It's a really large group now. I think it's like 30 or 40 women who want to learn, who've never had experiences working with tools, working with their hands, working with lathes, and all those kinds of things, and also felt uncomfortable. I mean, that was the message that I got from them. They felt uncomfortable working around male students that had those experiences, and wanted to kind of have a community of their own to learn on their own. And they're just doing extraordinary things. I mean, it's amazing how excited these young women in engineering are. And so we can provide those kinds of activities outside of the classroom that promote inclusiveness and diversity and equity in everything we do. So that's just one example.
Thank you. That's a great one.
And I want to say the thing that's really important to me about that story is they took it upon themselves to do this. This wasn't, anybody at the college level or anybody else saying, hey, you should do this, right? It was them saying, we want this, we need this. And what we see by providing the opportunity for them is just this thriving community, which is inspiring to me.
Thank you. Okay, so I think we have time for only one more question. So I'm going to apologize to the audience. I know that questions are still streaming in, and so we won't be able to address them all. But the next one I have here, and the last one for this session, feels a little directed at me, but I'll let you answer. How can UCD entice undergrads in this environment to continue on to graduate studies?
I mean, I can take that because it's something that is really important to me, and our associate dean for graduate studies knows that that's one of my two big things that I wanted to focus on as associate dean is how do we broaden participation at the graduate level. A big part of that is providing opportunities at the undergraduate level for those who, many of whom would never think about going to graduate school, to get excited about exploration, to get excited about research, to provide research opportunities. And what I'd really like to do is to develop a program at UC Davis that educates PhD students who are interested in going into academia in how to be good mentors, sort of mentoring process for them so they can learn, and then to team them with undergraduate students, particularly undergraduate students who are historically underrepresented at the graduate level, to just mentor them and excite them about the possibilities of graduate school and continuing to explore and learn in graduate school.
Thank you. Chancellor May, would you like to add something?
No, I believe strongly in graduate education. I'll just say that when I was an undergraduate, I had a really pivotal experience by a former mentor of mine. His name is Howard Adams. He ran a program called GEM program, which was a graduate fellowship program for minority students. And he gave the best speech to motivate students to go to graduate school I've ever heard in my life to this day. And I wish I could repeat it to you. We don't have time. But basically, when you get a graduate degree, it opens doors. You have options. In engineering, it's free. So free things that do good are worth having, right? So I'll just stop there. That was the best motivation I've ever had, though.
Okay, well, thank you both. Those were great answers to that question and all the questions before them. It was great to have you both here. And thanks again. I'll hand it back to Leanne.
Great, thank you, JP, and thank you so much, Chancellor May and Dean Corsi. This was really fantastic insights, and I am so sorry that we didn't get to everybody's question tonight. There were a few more, but you can reach out to our team, and we can connect you maybe on the side with one of our leaders if you are dying to ask your question to one of our engineers. Let's see, I guess round of applause at home for everybody's participation tonight. Thank you to our engineering community for joining us for our Engineering on Tap. And now onto our raffle giveaway. So we are going to share, so we're going to say goodbye to Chancellor May. He has to go to dinner. Thank you, Chancellor May. And we will share our screen for our big wheel of fortune that we have with everybody's name. And we will find out who our first raffle recipient is. Michael Morgan, congratulations. A member of my team will reach out to you and facilitate the exchange of a $25 gift certificate to the UC Davis bookstores. The anticipation is intense. Mabube. We will also reach out to you for a $25 gift certificate. Again, thank you for joining us, and we hope you will attend some upcoming events. Before you leave, a shout out, we have a lot of information on our alumni page, engineering.ucdavis.edu. Spring quarter, we're featuring 3 alumni events, and we hope you can join. Picnic Day is in person this year. Hooray, April 23rd, mark your calendar and plan on stopping by Kemper Hall and Boehner Hall for the Alumni Lounge to say hi to Dean Corsi and to some of your favorite faculty. On May 10th, our spring edition of Engineering on Tap will be at Jackrabbit Brewing in West Sacramento. So if you're local, we'd love to see you in person at Jackrabbit. This presentation at Jackrabbit will be with Jeff Schlato, a civil engineering professor and founding director of the UC Davis Tahoe Environmental Research Center. And finally, we are always in need of excellent volunteers for our Engineering Design Showcase, which is going to be held in person at the ARC on June 2nd. So keep an eye out for the next Alumni Network news. Please go to our website for the most up-to-date information. Take care of yourself, and as always, go Ags.